Welcome back to our YouTube channel Easy Explanation. In this video tutorial we'll be learning about multidimensional array in C and more specifically two-dimensional array in C programming language, and we know that two-dimensional array is also called as matrix. So let us see some of the concept behind matrix. So how the element of matrix are represented and how matrix can be represented. Let us say we have a matrix like this: 10, 20, 30, 40, 50 and 60, and this is a matrix A. You can see the size of matrix A is it is 2 row and total 3 columns. So you can say that it is 2 cross 3 matrix, and you can represent the position of each element as something like this. Let us say this is index 0, index 1, 0, 1, 2. So columns are numbered from 0 to 2 and rows are numbered from 0 to 1. So individual element of this matrix can be represented as A of 0, 0, and then A of 0, 1, A of 0, 2, and again for the second row we have the element as A of 1, 0, A of 1, 1, A of 1, 2. So if you need to refer any of these elements, then suppose I want to access 20, then you can write A of 0, 1. So it is indicating 0th row and 1 column. So 0th row is this and column 1 is this. So this element will be referred. So it will return 20. So we will be using the same concept in order to implement 2D array in C programming language. Now let us say we have a matrix or 2D array something like this: 10, 20, 30, 40, 50, 60, and the row are indexed from 0 to 1 and columns are indexed from 0 to 2, like 0, 1 and 2. And let us say it is a 2D array A. Then element of the position of each element can be as A of 0, 0, A of 0, 1, then third element will be A of 0, 2. Then for the second row we have A of 1, 0, A of 1, 1, and then last element will be A of 1 and 2. Okay, now you can see we can generalize the position as, first we have to write array name. Let us say array is A, then the first value will be row and the second value will be column. Okay, so we can generalize it as A of row and column. So it is COL, column, A of row and A of column. So we'll be using the same concept in order to implement multidimensional array or 2D array in C programming language. Now let us write one code in order to understand this. So I'll create sample underscore mat dot C program to understand 2D array as include stdio.h int main. Now let us declare one multidimensional array first. Now since it is called as a multidimensional, now then it will have a 2 dimension, one is row and another is column. So it will be represented as similar to what we have learned here, as a row and column. As total size we have to specify. Let us give the array as of size of 100 and column size as 100. Now we'll be declaring two more variable m and n to in order to indicate the actual size or how many elements you want to store there. So printf enter the size of matrix. Scanf %d %m and %n. So actual size of matrix will be represented by the variable m and n. Okay, now let us enter some element into the matrix. So total number of element that we need to enter depends upon the value of m and n. If m equals to 2 and n equals to 3, then total we have to enter 6 element. So we'll ask the user to enter the elements now. So printf /n enter the elements of matrix. So how many element? Enter %d elements of matrix, and this %d will be given by m into n. Okay, now you can see here again we need two variable I for row and z in order to keep track of columns. So row will be tracked by I and column will be tracked by j, something like this. So for the matrix we have 10, 20, 30, 40, 50, 60. For this row I'll represent row as I, and for column we'll be using the index j. Now for each I, our j should run how many times? 0, 1, 2 times. Now for each I, our j should run 3 times. Once this is completed, we have to move to the next I. Okay, and again for this row, again our j should run how many times? 3 times. So it is similar to the concept of nested loop. So we'll be using outer loop for I, and our I should run how many times? So row number of times. So it will be I less than 2 and I plus plus. And similarly for each value of I, our j should run how many times? 3 times. So for j equals to 0, j less than 3 and j plus plus. Now then we will be performing the operation that is required here. Okay, so we'll be using the same concept. So for that, for I equals to 0, I less than number of row. What is the number of row? M, and I plus plus. Then again for j equals to 0, j less than n, j plus plus. Now what I have to do is, since you need to enter the element, so element will be entered at position of a of I and j. So scanf enter the element at the address of a of I, j. Let us see how this will work. Now for I equals to 0, our j should run how many times? If the value of m, let us say m equals to 2 and n equals to 3, for each value of I, our j should run 3 times because the value of n is 3. Now you can see here, starting the value of j will be 0, then we will be entering the value at the position of a of I is 0, so 0 0, and then the value of j will be incremented. Now the value of j will be 1. So now again enter the element at the address of a of I is 0 and j is 1. Similarly again increment the value of j, which is 2. So 2 is less than n. So again enter the element at the address of 0 and 2. Now the value of j will be 3. Now you can see 3 is less than 3 is false. So our this inner loop will be terminated. Now we have successfully entered the element at all these three positions or in the first row. Now once this loop is terminated, we will move to the outer loop. Now the value of I will be 1. Now for each value of I equals to 1, our j should start from 0 and move up to 2. So again we have to first enter the element at index of a of 1 comma 0, and again a of 1 comma 1, and finally a of 1 comma 2. Now in this way we can insert the element into each row. So I hope every one of you understood this concept. So it is based on the concept of nested loop. If you do not know how nested loop work, then please refer to another video tutorial that we have uploaded in this channel. So now once we have read the value into the position of the array, now let us display these array elements. I'll write printf the array elements are. Again we need two loops, one for tracking the out row and another to track the column. So for I equals to 0, I less than m, I plus plus. Again for j equals to 0, j less than n, j plus plus. So in order to print the value, we'll be using printf statement. The first print element at position of a of I, j. So in the similar manner that I have discussed over here, all the element of the array will be printed. So all the element of first row will be printed first, then our loop will move to, or iterator will move to the second row, and then it will print all the element of the second row. So after printing the element of first row, what we have to do is we have to break the line. So printf /n, and write /t here in order to give the spaces between element. So it will print the first row first, then after the value of I will be incremented, we will be printing the next row, but before printing the next row we have to break the line. So I have given /n over here. Now write return 0 in order to terminate the program. So this is the program to understand the 2D array. Now let us compile this code. We have cd, so I'll write gcc ./a.out, enter the size of matrix, let us say 2 row and 3 column. So total 6 element I have to enter. Let us say elements are 10, 20, 30, 40, 50 and 60. You can see, so I have first printed the first row and then the next row. So in this way you can insert the element into the matrix, and then you can display the element or perform whatever operation you want on the matrix element. So if you want to give another input, let us say size is 2 and 2, and element are 1, 2, 3 and 4, it will be like 1, 2 and then 3 and 4. So in this way we can write C program in order to read element into the matrix. First declare the matrix, declare the size, insert element into the matrix, and then perform whatever operation you want on the matrix. After that, let us learn different way to declare and initialize the array. So declaration and initialization of 2D array. Declaration and initialization, like different technique to declare and initialize the 2D array. Now let us understand this concept also by one example program. So dec underscore mat.c, we'll be learning about different way to declare and initialize 2D array. The first hash include stdio.h int main. Okay, now we know that if you are initializing the array during the declaration, the size need not to be specified, right? If you are declaring the one-dimensional array, I'm talking about one-dimensional array. If you are declaring and initializing the one-dimensional array at the same time, then you need not to mention the size. The similar case apply also here. So first understand the basic way of declaring and initializing the multidimensional array. Let us say I have array A of size 2 and 3. So we can initialize this array by total of 6 elements. So we need 2 row and 3 column. So for that we need to create 2 one-dimensional arrays of size 3. So first one-dimensional array of size 3 will be 10, 20, 30, and one more one-dimensional array of size 3. So 40, 50, 60. Okay. So from that what we can conclude is multi-dimensional array are composed of number of two-dimensional arrays. So here we can say 2D array contains one or more quantity arrays, right? So you can see this is one-dimensional array and this is another one-dimensional array. So in this way we can declare and initialize the two-dimensional array by using number of one-dimensional array. So we can read this as int a of 2, 3 can be read as, so int a of 2, 3 can be read as create an array A of size 2, create an array of size 2 and array of size, instead of size we will be writing create an array A of 2 one-dimensional array and then size of each one-dimensional array should be 3. So create 2 one-dimensional array. See, this is one and this is another one-dimensional array, and size of each one dimension should be 3. So it has 3 elements, another it has again 3 elements. Now once we have declared this array in this format, declare and initialize the array, we can display or perform whatever operation you want on that 2D array. Let us say I'll display the array. So I comma j. So printf /n the array elements are for I equals to 0, I less than 2, I plus plus, and again for j equals to 0, j less than 3, j plus plus, and again write the printf statement, printf /t a of I j. So after printing one row, break the line to print the next row. So /n. just compile and execute this code. So gcc dec underscore mat dot c dot slash a dot out. So elements of array are 10, 20, 30, 40, 50, 60. I'll format it. So I'll write it here /n. Okay. Now in this way you can declare and initialize the array at same time. So this is one way. This is one way in order to. So this is one way to declare the and initialize the array. There can be another way also. So I will declare this int ing separately first. Int I comma j. Okay. Now we'll be focusing on that. So this is one way to declare and initialize the array. Now let us understand another way. Now int a of 3 equals to or 2, 3 equals to, we can simply write 10, 20, 30, 40, 50 and 60. We can simply write without including these individual array into separate bracket. We can simply write like this continuously. A of 2 comma 3 is 10, 20, 30, 40 and 50. So what compiler will do is, compiler will take first 3 element, make it as a first row, and then it will take next 3 element and make it as a second row. So in this way we'll have 2 row and each row will have 3 columns. So in this way also you can declare and initialize the 2D array. So let us compile this code again and see the result. We are getting the same result. So this way also it works fine. And one more thing that you need to understand is, I'll write it here, while declaring the 2D array, it is compulsory to mention the second dimension that is column, size of column. It is compulsory to maintain the size of column, but first dimension, which is row, is optional. Okay, so second dimension, which is row, is optional here. So we can write this array in some other format also, like this. Control B. So we can omit this thing. We can omit the first dimension, which is the row size, and can have only the second dimension, which is the column size. So what the compiler will do is, for such type of statement, it will take the first 3 element, make it as a first row, then take next 3 element, make it as a second row. So you can see, by omitting the row size also we can declare and initialize the array. So this is another technique to declare and initialize the array. So if I compile this code and see the result, we will get the same result as above. You can see we are getting the same results: 10, 20, 30, 40, 50 and 60. So we have learned 3 ways in order to declare and initialize the array in 2D array. Now let us understand one more concept: 2D array and pointers. 2D array and pointer. So we will be learning about the concept like how to represent 2D array by using pointer, or how to manipulate the 2D array using pointer. for that, let us understand one by diagrammatically first, then we'll be writing the code for this. Okay. So let us say we have an array 10, 20, 30, 40, 50, 60. As we have already discussed, 2D array are nothing but they are composed of multiple one-dimensional array. So this is one-dimensional array, and this is another one-dimensional array. Suppose it is indexed from 0 and it is indexed to 1, and it is A, and this is 0, 1 and 2. We know that if you know the base address of any array, we can access each and every element. So the base address of this array, or the first one-dimensional array, is given by A of 0. Let us say A of 0 give you 1000. Once you know the base address of the first element, then we can access the next element by, so A of 0 give you the base address of first one-dimensional array. Now A of 0 plus 0 will point to, will give the address of 10, will give the address of, or return address of element 10. Similarly, A of 1 plus 1 will return address of 20. Similarly, A of 0 plus 1, A of 0 plus 2 will return the address of third element, which is 30. Okay, so in this way, if you know the first address, we can access all the element of the given row. So A of 0 will give you the address of first one-dimensional array. Now in order to get the address of second one-dimensional array, we can write A of 1. A of 1 will return some values like, so it is, suppose it is 4 byte and it starts from 1000, then it will be 1004, 1008, and then it will start from 1012. So let us say 1012 is the base address of second one-dimensional array. 1012 is base address of second one-dimensional array. Now we can refer to element of the second dimensional array as, the second one-dimensional array as A of 1 plus 0 will point to this address, A of 1 plus 1 will point to this address, and A of 1 plus 2 will point to the address of 60. Now we can verify this result by writing one simple program. So pointer and 2d dot c, program to understand pointer and 2d array. So hash include stdio dot h int main. Let us say we have an array int A of 2, 3 equals to 10, 20, 30, and then we have 40, 50, 60, something like this. Now to get the base address of each array, the base address of this first array and base address of next one-dimensional array, we need one loop. For that, I will declare variable I, or I will write here print base address of each 1D array. Now for I equals to 0, I less than 2, I plus plus, printf /m address of %th row is percentage u slash n, okay, I, and it will be given by a of I. Address will be given by a of I. Now let us compile this code and see the result. Return 0. ls we have pointer underscore 2d, so gcc dash w pointer dot slash a dot out. So you can see the address of 0th row or the base address of the first one dimensional array is 08, okay, 08. Then we can get the next address or the base address of the second row is 20. So you can compute this address. So it will start from 08, 012, 016, and then we'll have 020. So the base address of the second array will be start from 020. That is the reason why we are getting the base address of the first one dimensional array as 08, and the address of second one dimensional array starts from 20. So in this way we can get the base address. Now let us print the element using pointer. Print the array elements using pointer. Now again for I equals to 0, I less than 2, I plus plus, and again for j equals to 0, j less than 3, j plus plus, and you can printf percentage d slash t. Now you can see you can access the value using this asterisk operator, asterisk of a of I and plus j, in order to get each an element of the first row and then the second row. So all the element of each column we can get by a of I comma j, which is similar to this, a of I plus j. So if you print the result, so I have to declare j here, j is declared now, and then printf new line to break the line after each row. Star a of I plus j. So star a of I plus j will give you the base address of each element, base address of first element, then second element, then third element, and this asterisk will help you to print the value at those addresses. So you can see this is the result. We have got 10, 20, 30, 40, 50, and 60. So in this way you can use pointer in order to represent the 2D arrays. Now how to pass 2D array into function. So pass 2D array as function argument in C. Let us understand this concept by also one simple program, example program. 2D underscore fun dot c. So C program to pass 2D array as function argument. So again hash include stdio dot h int main, then we'll be using the same concept here. So I'll be copying all these contents. Control C, Control V here, declare an array of size 100, and the size will be stored in m and n, and I and j will be used to control the outer loop and inner loop. Now once we have an array declared and initialized, let us pass it into the function called as a sum. So what a sum function will do is it will sum all the elements of the array. So our function will perform this operation, like suppose we have an array like this. So I am writing one function array like 10, 20, 30 and 40. So our function will add 10 plus 20 plus 30 plus 40. So it will print the result as 60, 30 plus 30, 60 plus 40 as a 100. So our function will should print the or return the value 100, which is the sum of individual elements of 2D array. So for that we will call the function sum, and in the function sum we will be passing array and its size as m and n. And finally we'll be writing return 0, return 0. Now since the function should return the sum value, which will be integer, so int sum, and then int arr of, then let us say 20, and then int r comma int c. Now you can see here. So as I have mentioned earlier also, in order to declare the two-dimensional array, it is optional to declare the row size, but it is compulsory to use the column size. So that is the reason why we have used column here. I have declared the column values. You can use it as 100, 200, whatever you want. So let us say it is 100 also, no issue. Now here array arr and array a is now pointing to the, like after calling this function sum a with argument a, now the array arr and the array a points to the same address value, so sorry, same array values or the same array. Now once we have passed the array into the function, we can perform whatever operation you want. So I'll write int sum equals to 0. Sum variable will store the sum of individual element I and j in order to control the inner loop and outer loop. Now let us write the statement for I equals to 0, I less than r, I plus plus, and again for j equals to 0, j less than c, j plus plus, and we can write sum equals to sum plus a of I j. So it is array arr. Now once the sum is done, we can return the sum value, return sum. Now since you are returning the sum to the main function, I'll be declaring one more variable called res to store the sum value returned by the function sum, and then I'll write printf /n total sum of all elements is equals to %d/n, and it will be given by res. So please have a good look at this code. Now let us compile this code and see if it works or not. So if there is an error, we will try to debug the code and solve the problem. So let us compile this code now. Clear gcc fun. ls 2d fun it is, so gcc 2d score fun.c. okay, the declaration is required. I missed the declaration or function prototyping, so I'll declare the function prototype also. Now once we have done that, let's compile this code again. Enter the size of matrix 2, enter the element 10, 20, 30 and 40, so it should return result as 100. okay, the total sum of all element is 100, so you can say our code is working perfectly fine. And in this way you can pass 2D array as a function argument. We are passing 2D array as a function argument in the function called as a sum here. Now let us write one more program in order to add the elements of two given array. Let us say we have array something like this. Let us say we have two array 10, 20, 30, 40. This is array A, and another array we'll have is B. It is 1, 2, 3, 4. We have to add these two array and produce another array as array C. So it will be added as 10 plus 1, then 20 plus 2, then it will be 30 plus 3, and then it will be 40 plus 4. So the resultant matrix will be 11, 22, 33 and 44. So what we have done here is we are trying to add a of, suppose this is 0, 1, 0, 1, 0, 1, 0 and 1. So we are adding a of 0, 0 with b of 0, 0. Again, in order to add this and this, what we are doing is a of 0, 1 plus b of 0 and 1. Similarly, in order to add this and this, we will be writing a of 1, 0 plus b of 1, 0. Now in order to add 40 and 4, we will be writing a of 1, 1 plus b of 1, 1. So its generalized term will be a of I, j plus b of I and j. So we'll be adding a of ij with b of ij in order to get result as this. In this case, you can see here, in this case we have I equals to 0 and j equals to 0. In this case we have I equals to 0 and j equals to 1. In this case we have I equals to 1 and j equals to 0. In this case we have I equals to 1 and j equals to 1. Again we will be using the concept of nested loop in order to implement this concept. So let us see this example again. So matrix underscore add dot c. So C program to add to matrix or matrices. So has include stdio.h int main. Let us declare two matrix int a of 100 by 100. Its size will be m comma n. Another matrix int b. You can declare all these things same line, but for easier understanding I am writing it in two line. For b of 100 100 and its size will be given by suppose P and Q. Then we need two variable I and j in order to track the row and columns. I will ask the user to enter the size of first matrix. So printf enter the size of first matrix, scanf %d then %m comma %n. Now printf /n enter %d elements for first matrix and it is given by m into n. So enter, like if m equals to 2 and n equals to 3, then your program will ask you enter 6 element like that. So for I equals to 0, I less than m, I plus plus, again for j equals to 0, j less than n, j plus plus. After that call the scanf function, scanf %d at the address of a of I and j. I will repeat the same process for the second matrix also. We'll ask the user to enter the size of second matrix. So Control C, Control V, enter the size of second matrix and it is given by P and then Q. Now in order to add the two matrices, its size must be equal. If the size are not equal, then we cannot add the matrices. So we'll write one condition here: if m is equals to P and n is equals to Q, if the row of first matrix is equals to row of second matrix, and if the column of first matrix is equals to column of second matrix, then we can only perform the addition operation. Otherwise we cannot perform addition. In else part we'll mention that else printf cannot be added. And finally write return 0. Now in the if condition part, means if the condition satisfied, we'll ask the user to enter the element of second matrix. So Control C, Control V, so you have to always do the proper alignment of braces in order to write the good program or readable program. So enter the %d element of second matrix and it will be given by P and then Q. I'll write here P and then I'll write here Q. Okay. Now once we have entered the element or initialize the second array also, after that we can perform the addition operation. For addition operation, again we have to use the loop for I equals to 0, I less than m, I plus plus. Since the size of both matrices will be same, we can use any of the dimension. For j equals to 0, j less than n, j plus plus. So you can see C of ij will be given by a of I, j plus b of I and j. This is what we have calculated So I have not included another array C, so you have to write int C of 100 and again 100. Once addition is done or the array C is initialized, we can print the result matrix as printf the result matrix is /n. Again we will using the same concept for I equals to 0, I less than m, I plus plus, for j equals to 0, j less than n, j plus plus, and we can printf %d /t c of I, j, and printf write the new line. So this is the complete code in order to add the two matrices, element of two matrices. So let us have a good view at this code one at a time. Then let us move to from line number 18. Now from line number 37 like this, if I can zoom out this code and see the result. So I have to zoom it like this, zoom out. Okay, I hope every one of you have got a good look at this code. After that, let us compile this code now. Clear ls, we have matrix add, so gcc matrix add dot c dot slash a dot out. Enter the size of first matrix, so we'll be using the same. This is of size 2, both matrix will be of size 2 and 2. So 2, enter the first element of first matrix 10, 20, 30 and 40. Enter the size of second matrix, again 2 by 2. Enter element as 1, 2, 3 and 4. So result matrix is 1, 2, 3, 4 only. So there is a mistake we have done somewhere. So what mistake I have done here is, instead of writing the address of second matrix, I have used the matrix address of first matrix only. So we have to replace A by B. So while copying, I have made that mistake. So you can correct the mistake at line number 27. Instead of A, we have to write here B. Now once you have done that, so make changes in the scanf function at line number 27. Once we have made the changes, let us again compile this code. So 2, enter the element 10, 20, 30, 40, 2, enter the 4 elements 1, 2, 3, 4. You can see we are getting the correct result now, 11, 22, 33 and 44. So in this way we can add the element of two given matrix. So in this video tutorial we learned about what is two-dimensional array, what is two-dimensional matrix or array, and what are the different way to declare the two-dimensional matrix, how to initialize the two-dimensional matrix, what is the relationship between pointer and two-dimensional matrix, then how to pass two-dimensional array into a function argument, then another example, how to add each and every element of the given matrix, and another example we discussed here is how to add the individual elements of each the two given matrix. So I hope every one of you have understood the concept. If you have any queries regarding this, please mention in the comment section, and please like, share and subscribe our channel for more videos and updates. Thank you everyone.